Hello and welcome to the deep learning course. Today we'll be going through the sentiment analysis model. Basically, we'll be focusing on the modeling part. We'll be applying some improvement techniques that can be computationally more efficient, and we'll be also using the LSTM as our backbone recurrent neural network. So let's get started. Previously, I need to just have a quick recap on the difference between GRU and the LSTM from a technical perspective, nothing more. Like the GRU is, as you can remember, it generates two outputs, the hidden state, which is last hidden state for the last token in the sequence, and the output matrix, which contains all the hidden states being combined together in concatenated together in a single side matrix. Okay, while on the other side, the LSTM here is the same as GRU unless it have an extra cell state, which we call here the cell, and it have the same dimensionality as the hidden. And I'll not be discussing much more regarding this, what is the cell state, because you can have a quick recap on the theory part that I have been previously discussed through the previous lectures. But in a short way, the cell state is just as information, how the information flow across all the sequence embedding within the LSTM cells, and how they can have they can watch what information have been being propagated through the LSTM whole sequence as a chain. Okay, so this cell state is somehow showing the flow or the propagation of information across all the internal LSTM cells. Okay, so let's start. First, I just imported some packages here, and then I can work on the modeling part directly. So for example, here I have created this list of random or the constant values, and here I just create a dummy example of how you can run a GRU. For example, here it is nothing but you can give it the X embedding values, because it should take three-dimensional values, which is this red matrix here, and this then being inserted to this GRU, and also can be inserted to the LSTM cell by the same way. And only the difference is the returning value here is just a single vector, the hidden, while here it is a tuple of two vectors, the hidden and the cell. And pretty much they have the same dimensionality as the same. And also I can take as a number of layers, I can pass the number of layers, the bidirectionality values. It can be true or false, and the batch first should be also set to true, because I'm having the batch size as my first parameter, as you can see here. Okay, so now let's start with the modeling part. First, I will be defining my three all knowing this embedding and this LSTM, and the last layer is the linear layer. Okay, the embedding takes the vocab size, the embedding dimension, and also takes the padding index to be defined in order to let it avoid learning the padded index, the padded values, the padded tokens, I mean. And the LSTM takes this embedding dimension and outputs the hidden dimension, and also can take this bidirectional to set to true or false, and the number of layers can also be set to true or false. And last thing is this batch first should be set to always true. I will be just passing these parameters as I finish this writing. Okay, so the linear layer should be taking this hidden dimension and output the output dimension. Okay, so that's pretty much what we need to apply here. Like I need to pass all of these parameters through the hidden dimension and also the number of layers and the bidirectional and the bad index and the out dimension. Okay, so that's pretty much what we're going to do, and I should be rename it, give it some name to each layer in order to call it back through the um, forward method. Okay, so here in the forward method, I can just drop them for now because they are not being important. And for the forward method, I can call all this method, but just to be aligned with the shapes. Like here, the shape should be batch size multiplied by sequence. Okay. And after I apply embedding, so I should be apply first this embedding on the X. The shape should be adding this E, the embedding dimension. And after embedding, I should pass it through the LSTM model, which is pretty much take this and output three outputs, the output, the hidden, and the cell state. I can also check the shapes of them all as the output and the hidden, the cell and the hidden will be pretty much the same. Only the output will be different. Like here, the hidden and the output will be layer by batch by hidden size, and here it will be the same as batch size, sequence, and hidden. Okay. And then after this, I will be pathing them through the LSTM and return this value back as the final output. I will just return the predictions like this. Okay, so here I can just create a random matrix, which is tokenization of each text. It should be the low value should be 1 because this is the padding index, and the highest value should be the vocab size because I cannot exceed this vocab, and the size should be batched by sequence. So I can define my model as pretty much as this. This is the vocab size, this is the embedding, this is the hidden, and this output is the C, number of layers is L, and bidirection is D, and padding index is bad index. So these are pretty much what I have written here. I just copy paste them back. Okay, so this is the model, and I just pass them to the model, and this is the prediction. So let's start. Okay, as you can see here, the predictions are pretty much the same, 32 by 2, which is each batch have two outputs, positive or negative, as much as I define within this output dimension. Okay, so now let's start with if I have bidirectionality set to true. So basically, I should be creating this number of layers within this hidden size. It should be multiplied by 2, and also the output might be affected. So for example here, the hidden instead of 1, it is now 2 by 32 by batch by sequence. This is the number of layers being checked within this part. Okay, and the output also have been multiplied by 2 because it have two matrices being combined together. Okay, And then I need to pass them to the layer. In such a case, like I need to concatenate the last forward layer with the last backward layer and combine them together to have the same output within this the output layer 32 by 2, not 2 by 32 by 2. Okay, so how can I combine them together? It is pretty much simple. Like I can hold the concat concat value, h of -1 should be the last forward layer, and this is the same dimensionality above them all. I can also remove them, it is not important. I might be, for better understanding, I can try some dummy example here. Can call it HR, call it random, and the size of it is two number of layers, which is here directionality, which is 2, and this is I just make the difference here, and the number of layers is still 1. Okay, just to make note of this. And here I multiply by 2 because I have this bidirectionality, and then the batch size, and then the hidden dimension. Okay, so it's here as this one exactly. So I should be combining the last hidden state of the forward propagation, and then like if I take the shape of this, it will be 32 by 21, and the last backward of this for backward propagation of the hidden dimension, and I will be concatenating them through torch.concat. I will be concatenating them, but I need to have some another parameters, like the available or the acceptable here is to be one of these tuple of tensors and the dimension, or tuple of tensors and the name of the dimension. So I give it, I should put it them in a tuple, and also give the dimensionality to be 1, because I need to concatenate them and keep this on the same number value will be 32 also. So the shape here should be 32 by 256. And in that case, I can increase the hidden layer with by 2 because it should accept multi double of the hidden size. So I can just concatenate the last 2 hidden states and put it in a tuple. And concatenate them. And this is the new hidden state. Okay, so pretty much this is the concatenation. I can check it again after increasing the number of hidden dimension to be accepted due to the bidirectionality, and also writing out the passing them again. As you can see, the same output here have been produced. Also, if I increase the number of layers to be 2, okay, so here again, if I run it, it should be giving me a little bit difference, but here I just have taken the last 2 layers, but basically I need to also check the last 4 layers because they are pretty much the same as I am taking the last hidden layers within each bidirectional, and also from the last layers. So here I'm taking this from the last layer, but I'm taking the last hidden state of last 4 tokens. But if I need only to take the bidirectional for the last hidden layer and last 2 tokens, so I should do the same as I have done here. So this is the last hidden state, the last layer, the second layer, and taking the last 2 tokens. So I should be pretty much fine with this. And it produces the same output as expecting. But I'm here, if I need to give it 4 tokens, if I need to take 4 tokens, then I need to increase a linear with multiplying it by the number of layers. Okay, but I don't care about this for now. I just take the last two, the forward and the backward, the last state in them, and regarding the last token within it. Okay, you can pretty much play with these values as you can. Okay, you can like do anything you can do. They are pretty much a research way. So also when we go to the bird and it have some 12 layers, some input to the last layer should be the last 4 embedding layers, the last 12 embedding layers, all the 12 being flattened within each other and passed to the linear layer. This can be trial and error. There is no a correct solution for this. It is just a research. You can take the last layer only and it gives you the best accuracy. So you don't know what is the best unless you try it out. So I'm giving you this knowledge to have this flexibility to check it out. You can also choose the cell state instead of the hidden state. Okay, so but it's maybe less common to use it and more common to use the hidden state, but it's up to you. Okay, so you can check it as you like. Another thing I might be improving here, or the last thing I can do, is I can here, as you can see, we have inserted this padding index to the embedding layer to avoid learning any zero tokens or any padded tokens, whatever the index is. So the embedding layer will not learn the distribution of these tokens. But here, the output of the embedding is still 40. Although if I have only 5-6 tokens within my patch, I will still have 40 dimensional torch tensor to be inserted to the LSTM, and the LSTM will be backward and forward propagating through it. So that's a lot of useless computation being done here. So in that case, I'm having Torch provide us with some nice method called back the padded sequence. So it will be packing them out. So in that case, the LSTM will not be computing anything regarding the padded sequence. So how can this be done? First, it should be taking the tensor as the input, which is pretty much the embedding, the X embedding. So if I have here created a random X embedding, I don't know if it have, okay, I have here already a random X embedding, which is 32 by 40 by the embedding dimension. And I just take, for example, the last, or maybe I just take first three tokens, first 3 sentences within this patch. Okay, and the embedding of them is 40. So I'm transforming all this sentence into a 40 sequence, even if this sequence are pretty much small. So if I have the length of each sequence within these 3 values, Like for example here, after the tokenization of the text of the reviews, I have this list of values. For example, 12, 78, 9, 70, and 0, 0, and 0. Okay. So this is a tokenization of a sentence. And I have also another one which have, for example, here, 6, 9, I think. Okay. And I have for this example, I have 0, 0. So all of these zeros should be avoided. Okay. They shouldn't be computed within the LSTM. So how can I do this through this back-padded sequence? If I inserted this X embedding with the first 3 tokens, it will ask me for another parameter, which is the lenses. What is the lenses of the non-zero tokens? What is this? What is the length of the first sentence without the padding? So basically, this will be 12, 1, 2, 3, 4. So it should be 4 here. So I should send it another tensor with this list. The first one with 4, second one with basically 8 or 7, I think, and third one with only 2. Okay, but basically it will give another error that this sequence should be sorted because it will be more beneficial, more efficient within its internal values. So if I just run it, it will be give me okay. I should also take care that the batch first should be flag should be set to true. And here it should ask me whether this should be sorted in the descending order, or you can say the enforce sorted equal to false. Okay, so as you can see here, I have these 3 values, and this is the packaged padded sequence. I can take it packaged output, and of course I don't have availability to check its shape because it is an object, but I have this data tensor, and then I can check its shape. So as you can see here, it is 13 by 300. Before it was actually 3 by 40. It was 120 value should be inserted to the LSTM, but now it is 13 because if you sum up these values, they will be 13. Okay, so these only tokens that I care about, and these only 13 tokens should be inserted to the LSTM in order to apply its forward and backward propagation. Because if I apply this 120 and I have a large corpus of data, this will be a lot of useless computation. Okay, so that's pretty much what the back-padded sequence do, and should be now inserting them back to the, and here I should be inserting them before the LSTM, of course, and giving it this X as the embedding. The lenses should be set to text len, for example, and this should be paused here within the forward lens. And lastly, I should take here that the patch first should be set to true, and enforce sorted should be false. Okay, because I don't care. I can also sort them out, but I just take care that they take care of it on their own. And this X packet, I can pass it through the LSTM normally without any issues. And I can here also write it back again, like this LSTM I have defined earlier as RNN, and it should take this pack padded sequence, as you can see, pack it out, and produce this output in the same way. Output will be this output, and this is the hidden, and this is the cell state. So hidden and the cell state will be pretty much the same, because here I have batch size will be 3, so it is batch size by 28, and also number of layers by batch size by 28, so it is pretty much the same, but the output here is having this issue, like it is now packed. If actually from the common cases, we don't care about this output value, but if we need, we can apply some another method called pad the packet sequence. If it is packaged, so I can pad it again and check it out. Like it will be having two outputs. One is the output again, original, and then the other side is the output lenses, and I can take the shape of the output. It should be 7 by 3 by 128, and this is the batch size, and 7 and the other part is the O lens, which is the 4 by 7 by 2, which is the actual lenses that I have imported here. Okay, but anyway, we don't care about these output values, because it is okay. I think I should also take care that the batch first should be true. Okay, so it's 3 by 7 by 128, and so it's batch size, and this 7 is the maximum length size. It takes the maximum length of these tokens, and by 128 as the hidden state, as it already take as the original output. Okay, but as you can see, the most common is to use the hidden or the com, but if you need, you can also use this output as you wish. Okay, so here I'm backing this padded sequence for after embedding. So I'm giving this back to the LSTM, and then taking out this output H and C, combining this edges last backward and last hidden within the forward, and combining them again, and produce this to the FC. Here the output also should be checking this data tensor, because it's currently packed. Okay, I should also add this text len to the model, because now I need another vector here. I can also generate this as a torch random. It should be batch size only, and the low value should be 1, okay, but the highest value should be the sequence, because each sequence, each sentence have a length of sequence. So the text length is basically the length of each sequence, so it shouldn't exceed this value. So if I run it again, it should be giving me this same output, as we can see. So basically, pretty much this is the objective of the lecture, to give you some tricks and how you can go on with the modeling with different variations, the bidirectionality, the hidden, the number of layers, and also the pack of the padded sequence. How can you use them? That's pretty much for today, and let's move to the next lecture tomorrow. See you there, and thank you. Goodbye.